do you want to tell me where we are?
Yes. We are in Computational Garden on the Lower East Side of Manhattan, walking through over on the pathways with crunchy leaves, and so far, no rat signs. But
On a cold night in November, community garden volunteer Houda took a few of us on a tour to look for rats.
Pink flags, that's where we found a rat burrow. Oh. So they might be close to where the burrows are. Actually, then we could use your camera.
Oh, yeah.
Yeah.
There is a rat squeak.
As in many other parts of the city, Computational Garden has historically had a big problem with rats.
We do try to avoid piles of garbage in the garden.
I hope so. In cooperation with the city, garden volunteers have been making efforts to reduce rat presence, not just to stop them from eating garden vegetables, but because rats can act as disease vectors to humans, damage infrastructure, and even cut wires to start fires.
Sorry, Houda. Not that many rats, I guess.
Yeah, it seems like your garden's doing a great job. That's awesome. And while it took some hunting at first,
I'm happy about this development.
eventually we found quite a few.
Oh, wait, there it is. It's running. Oh my God, it's running. Wait, there are two rats?
There's 2 rats. What are they doing?
They're running towards us in a menacing manner.
Using a thermal camera, in my case, a cheap one from Home Depot, we could see the rats pretty well even in the dark or in their burrows.
Oh wait, do you think that's it? Oh my gosh, I think we can see it in the burrow. Look, can you see it how it's moving around?
Yeah.
Whoa, that's a lot deeper than I would have guessed.
It's coming back out. Oh, it just
my God.
What do you think about your community garden pest management now?
Well, technically this is outside of our formal jurisdiction, so I'm still feeling pretty good.
All right. We need Shweta on it. Oh my gosh, there's so many here. Hi, I'm Houda Khaled, and this is Frivolous Science, where I talk to scientists conducting seemingly silly science, the kind you hear complaints about on Fox News.
Well, I compliment Secretary Kennedy and the Trump administration for finally saying enough's enough. We're not going to keep funding frivolous and crazy research.
And even NPR.
Those scientists know we need to cure cancer, right?
But they can actually have a big impact on our lives. Today, I talked to scientist Ralph Peterson, whose passion for understanding rodent vocal communication might indirectly lead to new solutions for rat pest control, just by listening in on their conversations. Ralph Emilio Peterson is a PhD in neuroscience from New York University, and he's also my former classmate. For his dissertation, he looked at the ways that rodents communicate vocally. He found some interesting things, like that gerbil families have their own unique dialects compared to other gerbil families. He's now a postdoctoral fellow at BASIS, where he's continuing his work studying animal vocal behavior in increasingly naturalistic environments. Would you say that's accurate?
Yes, very accurate. Nailed it.
Yeah. Also, you're a musician.
Yeah, I grew up playing jazz trumpet. That was one of my first loves in life and passions. And that was actually what inspired me to go to grad school and study the auditory system. I was always kind of fascinated by how music could invoke emotion. There's this really kind of surreal state that you can enter when you're playing music, and specifically jazz, when you're improvising, and it feels like you're transported somewhere new. It's this very kind of euphoric state. And so I was always curious how it could be that music could interface with your emotions, and how they're so kind of intertwined. So when I went to grad school, I decided that I wanted to study sensory processing, auditory processing, to figure out, how sound hits the ear and travels through the brain and may or may not interact with emotional systems. And I specifically focus on vocal communication because it's so central to everyday life and in every species, and so very much intertwined with emotion. For example, if you're on the phone with, a family member and they're not feeling well, they're sad or something, you could tell in their voice that they're not doing great. So the voice, in a sense, is like a readout of, the soul, if you will. There's a lot of information other than just the semantic content of the vocalization that you can read out from speech.
Yeah, I think that's pretty intuitive to people's experiences, and I feel like that's a really good example. So then, what made you veer towards animal research rather than, I don't know, looking at humans and emotions? It's hard to read out the emotion of a gerbil or a rat.
Yeah, it's a good question. There is some great work going on in human vocal communication. People like Eddie Chang or like Michael Long are doing experiments in humans as they're freely vocally communicating. But there are some caveats. These are people going in for procedures to treat strokes and whatnot. It's a very stressful environment. So I thought it'd be interesting to look at rodents. They're a standard model organism in neuroscience. They're highly social and they speak in this ultrasonic frequency that humans can't hear. So there's a bit of mystery as to what they're saying. There had been, decades of research in gerbils specifically studying their auditory system because it was very amenable to auditory experiments. And in like a parallel but totally non-overlapping area of research, there's been a lot of field work done in gerbils to study their social capabilities. They have this kind of intricate social structure. They live in these underground burrow systems with multiple generations of pups in there, children in there.
Versus other animals where the pups would leave the nest and form their own families. Exactly,
yeah. That's like the human model where you grow up with your siblings and then you're kind of forced to disperse when you're 18. That's not the case in gerbils. It's like a big, Catholic family where they're all kind of helping take care of each other. But the unique and kind of interesting thing about gerbils is that some of the older siblings will take on the role of caretaker. So they'll undergo like a sexual suppression where they actually cannot biologically reproduce. So they assume this role of caretaker called alloparenting. There's a study showing that the mother will force dispersal of specific individuals in the family based off of criteria that we don't really well understand. And there's studies in other rodent species that show that in their burrow systems, they have dedicated chambers for like using the bathroom or caching food or just nesting. So there is this idea of they're living in a big group that's not just a random big group. There's structure to it and there's hierarchy. And so I wanted to understand how they use vocalizations to coordinate their social hierarchy and basically understand how the brain processes vocalizations at a neural level.
So what makes you think that's the likely way that they're communicating? Because there could be all sorts of methods of communication. They can touch each other, look at each other, bite each other, or use pheromones.
Yeah, absolutely. I think that it's likely that those other senses are involved as well. But if you think about a day in the life of a gerbil or a rat or most rodents, living underground, there's not many visual cues. They have this really acute sense of hearing and vocalize a ton. If you record a family of gerbils 24/7, like I did in my PhD, they're vocalizing hundreds of times per hour. So they're not vocalizing to no end, I assume, and in very low lit conditions, I assume they're using it for something. The act of talking is one, metabolically expensive, like you need to expend energy to actually talk. Two, it's evolutionarily potentially precarious because you're exposing yourself to predation. So there are species that can hear in the ultrasonic range, like cats, for example, that could in theory hear them and run after them and attack them. So all that to say, I don't think that they're vocalizing just because they can. I think that there is a purpose and it's not clear in the field what that purpose is.
Yeah, but then the way that you say it makes it sound like it's actually pretty obvious. So then there's the alternative question, why haven't people been able to figure it out? Does it have to be... Does it have to do with it being computationally difficult, since that's a big focus of your thesis in preprint?
Yeah, it's difficult. It's just technologically difficult generally. So yeah, on the computational side, quantifying behavior in animals is a difficult thing to do. As I mentioned, there were decades of field work that were done in gerbils that were done by humans that wrote down on pen and paper field observations. Over the last, 10, 15 years or so, there's been this emergence of machine learning in the field of animal behavior and neuroscience, where instead of, looking at animals behave and writing down with pen and paper what they're doing, you can actually use machine learning to extract their calls and quantify their vocalizations in principled fashion.
And what are the benefits of that? I feel like we've learned so much from pen and paper and just observations, but what greater information do we get by collecting such large amounts of data and quantifying it?
Yeah, so one of the things we found in our studies in graduate school, we found that the gerbils emitted new and different vocal types than had previously been observed. And we think that this was in part because we put them in a very kind of naturalistic situation, so a family all together, and we recorded 24/7 for the period of 3 weeks. So we just kind of eavesdropped on whatever they did. If an ethologist, 30 years ago were to do the same study, they would have to listen back to this audio over 3 weeks and like individually annotate every single time there's a vocalization. It's just not a very scalable approach if you want to record data at scale. And I think what scale gets you is insight into new and potentially, rare events that occur. A lot of these field studies, if you read back to the methods, they like observed behavior for 2 hours because, that's all they could muster, basically. One of the things I began to appreciate and, become increasingly inspired by in my PhD was this idea that animals evolved to thrive outside of the laboratory, yet we bring them into the laboratory and kind of constrain them in these relatively reduced environments in order to gain experimental control, to understand how the brain works. So the idea that like the lab mouse that we study has been born in a lab, was shipped to us in a FedEx box from one lab to another lab and lives in a small, very reduced cage. And then we go in and we do a bunch of neuroscience experiments and claim that we've discovered something about how the brain works. Feels a little unsatisfying to me because this mouse, evolved to live outdoors and in the natural world and with its family and with the stress of predation.
And not unlimited food.
Yeah, exactly. So there's this idea that everything that we understand about the brain comes from this limited set of behaviors that are studied in the lab, and whether or not they generalize to how the brain works outside of the lab is still an open question.
So you think that in auditory communication, there's a limited repertoire, so that a lab mouse will only communicate in more limited ways because they're not having all of the life experiences that a normal animal has, or that a human would have, to extrapolate from these animals to humans. So that if we were to look at an animal in a real environment that's experiencing a full life, you'll find out new things about auditory communication as well.
Exactly. You nailed it. Yeah. That's 100% the thesis for this type of work. Is let's go into the wild and first just kind of document and record what the different types of vocalizations are. Then let's quantify them and see how they match with what we see in the laboratory.
Dr. Peterson's fascination with studying animal behavior in natural environments began during graduate school with his research on gerbil families. However, he's now taken it to a whole new level. Today, instead of working with animals in a lab, he ventures into the wild, exploring places like Central Park, subway stations, and rat control zones around the city, following rats where they go with his microphone and camera in hand. He talked about how this project got started, how they were able to do it, and the interesting things they've discovered so far about rat behavior in the wild.
The project came about when I reached out to Emily Peterson, who is one of the co-founders at Basis. She'd been recording birds in Central Park using thermal imaging, interested in how groups of birds forage. So we met in the park one day. She was showing me her equipment, and I was coming from an interest in communication. So I'd asked her, are you recording sound? Have you seen any rodents? What's going on? She's like, we haven't focused on rodents, but she's interested generally in urban species. So we basically decided we would go out together. She would bring her thermal camera, and I would bring my ultrasonic microphone. And that we would attempt to just document some rat behavior, not really knowing what we'd expect. It was that kind of fun, pure type of science that you do just because it's cool, not because you have a super precise hypothesis. So it was very discovery-based to start. And yeah, we went on a few nights and just scouted some areas. We went up to Harlem. There's this area that was marked as the rat mitigation zone where they had a high density of rats. So for anyone else probably in the city, they want to stay away from the neighborhood. But for us, we decided to go right in there. And it was quite amazing. So one of the advantages to Emily's thermal imaging camera is that it detects heat. So you can image through occlusion. So like if the rat is running around a bush in the park, you can see through the bush because the heat propagates through the bush. Yeah. So in cases where a regular camera would be occluded, the thermal camera kind of opens up a whole different realm for you. And on the microphone side, I have this little handheld thing here. It's like maybe half the size of a credit card in length and width and about as thick as like my thumb. Basically, I went out with this thing and I would point it at groups of rats, just hold it in my hand about 2 meters away from them.
2 meters. Okay, so you have some distance. There
was some distance, yeah. And they weren't, these are New York rats. They're not scared of people. So it was plenty of distance for me to record some really high quality vocalizations. And it was just amazing that first time coming back, loading the SD card into the computer and seeing them.
Because you can't hear it at all since our ears can't detect ultrasonic vocalizations.
Yeah, so human ears can hear up to about 18 or 20 kilohertz. Rats vocalize anywhere between around 20 and 50 kilohertz. So yeah, next time you're around in New York City at night and you see a bunch of rats, just think to yourself, like they could be, having a full-on conversation to themselves and we would never know. So there's something about that really intrigued me. First of all, we were able to record them. We saw that there were these beautiful sequences of ultrasonic vocalizations. It wasn't just like 1 or 2. It was like a sequence of 20 or 30 in a row.
Very chatty.
Very chatty. Presumably it was coming from one of the animals because there weren't a lot of overlapping calls. You can usually tell if 2 of them are talking at once because the calls will overlap with each other. So again, it piqued my interest about this idea of kind of social coordination. It's like, what is the relationship of these animals? What are they talking about? What are the features in the world that they care about? And just why are they talking?
Before we keep going, I think it's time for us to finally listen to what a rat actually sounds like. This is a recording from Dr. Peterson's study, pitched up so that we can hear it. So cute, right? Is that what you imagined? Like Dr. Peterson explained, these calls can come in a range of frequencies that have been associated with different meanings or social contexts, based on studies in the lab. For example, the one I just played was originally closer to 20 kilohertz frequency, which is usually thought to be an alarm call, while calls closer to 50 kilohertz are thought to happen while rats are eating or looking for food. And these are both different from human audible squeaks, which are mostly in negative situations, like if a rat gets hurt or in a fight. However, all of that data comes from watching rats in the lab, and what Dr. Peterson found in rats in the wild did not always match up.
So that was one of the big takeaways from this preprint, is that there's a couple of things. The first thing is that the contexts in which we see some of these 22 kilohertz alarm calls emitted have not been observed before. So as I mentioned, 22 kilohertz is like an alarm type of call. And to my knowledge, it hasn't been shown that they use that call type during foraging contexts. One of the things that I saw a rat jump into a trash bag and I pointed the microphone at the trash bag and, eventually it came up with a piece of food and ran away. And it was emitting very long sequences of this 22 kilohertz alarm call, in this foraging context.
Here's a clip of that rat in a trash can. What a cutie.
So it was a little bit paradoxical. It was like, shouldn't that be a positive situation? But, maybe things work differently in the wild. Maybe actually the intent was to alarm people because it is up above ground and it's scared that it might, run into something while it's in the trash.
So it's just like trying to tell other rats, keep an eye out for me?
Could be. Yeah, could be. That's one of my theories for what the function of these calls are, is essentially like an acoustic beacon. Like, I don't know if you've ever played Marco Polo.
Sure.
Kind of like that, where you say a vocalization, it reports your position in space. Another animal says its vocalization, reports its relative position in space. That way you're creating this spatial map of where your conspecifics are, where your friends are. Yeah. Again, the difficult thing about doing these experiments in the wild is that, and this wasn't necessarily the intent of the study, but it's more difficult to do like a manipulation to prove any one of these theories to be true. If we were in the lab, we would have a rat with different types of food sources and a speaker and a microphone and all these other equipment to test this idea that maybe they're using different calls depending on like the nutritional value of whatever they found, for example. In the wild, we're just kind of like eavesdropping and like hoping that we record enough data to make these correlations. So I can't really say with any certainty what it is they're talking about just because we don't have enough data to really say. A kind of zany dream of mine is actually to have like a research dumpster equipped with microphones and cameras and the ability to actually, manipulate the types of food that we're putting in the bags. I think it would be really fun, next direction here.
Yeah, because it seems like the big issue, the limitation of environmental recordings is that you don't have a good handle on manipulating the environment as you would in the lab. But the limitation of the lab is that you're limiting everything about what the rat is experiencing. So it seems like the research dumpster would be a good in-between.
Exactly. Yeah. And, the more and more I'm working with this kind of unwieldy data, the more and more I'm feeling like some sort of compromise like that is necessary to get to these causal questions that you're asking.
In addition to their findings on rat vocalizations, using thermal camera imaging, Dr. Peterson was able to draw some preliminary conclusions on rat behavior from their video recordings. He describes how rats seem to coordinate their movements, moving all at the same time in what he calls a burst. Kind of like what you see when a group of deer suddenly all run into the forest, or, more New York relevant, when pigeons all at once take to the sky.
So we tracked a big group of like 20 rats or so, and in looking through the video, we noticed that there are these periods of time where they would kind of burst, and they would leave the frame, leave the field of view, and come back. But it wasn't all 20 animals. There was these bursts happen every couple minutes. I think something, in the environment scared them away or something. So we were like, okay, what can we say about the animals that are bursting versus non-bursting? Is there any difference between them? So we estimated the size of each of the animals of the 20 animals.
I love that figure, by the way, because when you showed the estimations of size, there's this nice bell curve with all the rats, because there's some variability in their size. Just some are bigger, some are smaller, maybe some are babies. And then there's this long tail, and then there's this bump. And at that bump, there's just this arrow with a picture of a squirrel.
Yeah, it's our rogue squirrel. Yeah, that made it in, which is like roughly 2 times the size of a rat. Yeah, it actually took, some pretty sophisticated, probabilistic modeling to get to the 3-dimensional estimate of size of each of the animals. So one of our co-authors developed a procedure to estimate the size of the animals. And then using that information, we started to look at the bursting behavior to see, whether or not there was anything interesting there. And basically what we found is that larger rats seem to be more bursty. So the bigger rats are the ones that run out of the frame kind of right away when there's presumably, like an aversive event or something. And the smaller rats were the ones that kind of stayed put and seemed to be, oftentimes they would burst, but only after the other animals had already burst. So they're like a step behind. So one of the things we're kind of speculating about here is that probably the smaller rats are somewhat younger. Yeah. So there could be this type of, real-time social learning that's going on where you're seeing, a real-time example of something scary happening in the world, large rat running away and showing, the younger rats basically how to behave in a proper context. Again, very speculative.
So just speculating, like the big rats already know how to respond because maybe they've seen or heard the sound as something they should be afraid of. But the younger rats don't know it yet, so they have to learn from the adults. But the idea is now that you have the tools to investigate that.
Exactly, yes.
We also talked about some future potential ideas Dr. Peterson has for the project, besides research dumpsters, that would help deepen our understanding of rodent social behavior in the wild.
Eventually, down the line, we'd like to do some perturbations or even potentially neural recordings and say, how is the auditory system different in the real world? What are the hearing capabilities of these animals in the real world? And how do they match up to laboratory-based animals?
Oh, hearing capabilities too.
Yeah, I mean, we didn't touch on this in our study, but if we're to speculate a little bit about what might be going on is you and I ride the subway in New York daily, I imagine, and it's extremely noisy down there. And, subway is home to many, many rats that seem kind of unperturbed by the subway system. So I would strongly predict that they have some degree of hearing loss going on. I would imagine, but no one's ever done a hearing test on a wild rat, to my knowledge. So this would be a base level type of question. Is measure, you could do, it's called an auditory brainstem response, ABR, to measure hearing sensitivity at different frequencies. And I bet if you were to compare a subway rat's ABR versus a lab rat's ABR, it would look significantly different.
Wow, yeah. I was thinking about it in the other direction. Coming from my background, I was thinking about learning in memory and enriched environments and how much that changes animals' cognitive function. I would think that maybe they would be more sensitive to a wider range of things because a lab mouse is experiencing such a limited number of sounds versus a natural rat in the wild.
Yeah, I could see that happening too, but maybe at a different level. So I would imagine that they could, that their auditory system is really good at categorizing sounds, more so than a lab rat's, for example. There's this idea of categorical coding of different auditory objects that people sometimes talk about in the field. And like you're explaining, living in an enriched acoustic environment with many more acoustic objects that your brain has to experience, I would imagine that the brain of a wild rat would be tuned to maybe differentiating between more acoustic objects. Yeah. But I think at the, before getting to there, that might be at the level of that might be a central nervous system processing question. I think before you even get there, at the periphery, at the level of the ear, I think that there's just going to be some probably cochlear damage.
Okay, so just at the level of being able to sense sounds versus interpreting them.
Yeah, exactly. And this is, being a bit speculative. But I think it would be cool to, one, at least do some of these auditory brainstem responses in wild rats. And two, to your point, it would be great to do some recordings and the auditory system and do some psychophysics. So whether or not they can discriminate between two different sounds in wild rats versus lab rats.
Now, let's revisit the big question. As taxpayers, is this research worth funding? Dr. Peterson's study is relatively low cost. The priciest equipment was a $10,000 thermal camera, while many tools, like a computer vision software called YOLO, were free. Still, research like this has relied on government funding over the years, covering costs like scientist salaries and equipment to study rodent communication in the lab and in the wild. So what do we gain from studies like this? Besides that, maybe we should consider distributing earplugs to rats to help protect their little ears from the subway. I think it's important to remember that vocal communication is an integral part of most people's lives. I was most reminded of this after my interview with Dr. Peterson when he started showing me videos of his adorable baby.
She sounds like a cartoon character.
Do you hear those giggles? Can't you sense her happiness talking to her mom? Vocal communication is something that's so important to us. It starts immediately after we're born, and it carries so much meaning way before we learn to speak, with frustration in cries and joy in those adorable laughs. For those who struggle with vocal communication, research in the animal auditory system has already led to life-changing advances. People with hearing loss who want to regain their hearing can receive cochlear implants, in part thanks to animal studies. But these technologies aren't perfect. It isn't an option for all types of hearing loss, and many recipients of cochlear implants still struggle to interpret sounds as language. Because of our limited understanding of how we interpret sounds in the brain, we don't always know why this is happening or how to fix it. A deeper understanding of social vocal communication could lead to better hearing solutions and even help other people with vocal communication challenges, like individuals with autism spectrum disorder or people after a stroke. In a totally different realm, Dr. Peterson's team is working with New York City to improve rat control. With an estimated 3 million rats roaming the city and millions of dollars poured into mitigation strategies that aren't solving the issue, this is a growing problem. And it's not just in New York. Other cities aren't faring much better. Their research suggests that ultrasonic microphones could track rat hotspots in real time and monitor how rats respond to control efforts. By understanding rat vocalizations, cities could refine their approaches. For example, using contraceptives in areas with many mating calls, or employing other strategies based on different rat behaviors. At the same time, researchers could gather more data to even better map vocalizations onto specific behaviors and improve pest control efforts. Dr. Peterson emphasizes that this is just the beginning, with much more left to learn. But this research could not only help cities combat rat infestation smarter and faster, it may also lead to breakthroughs that improve the lives of those with hearing and communication challenges. So what's your final verdict? Thank you so much for listening. This is my first episode, but look forward to another one in the new year. And if you enjoyed it, please share with your friends. You can find the entire transcript and a link to Dr. Peterson's preprint on our website, frivolouscience.substack.com, along with thermal imaging videos from my trip to the community garden, and much better ones shared with us from the original study. Frivolous Science is made by me, Houda Khaled, with music by Blue Dot Sessions. Thanks to our Rat Garden Party, Shweta Pidwarden, Anat Mano, and Natalie Oppenheimer, and to the many friends and family who have been incredibly supportive. And extra special thanks to our guest, Ralph Emilio Peterson. You know, we were talking after, and I asked him about how he met his wife. He said it happened at a party where he walked right up to her and won her over with one line.
So I'd asked her, are you recording sound? Have you seen any rodents? What's going on?
I'm surprised that worked. Well, I'm Houda Khaled, and this was Frivolous Science. See you next year.